The ArangoDB PyG adapter helps developers move their graph data in between ArangoDB and PyTorch Geometric, a graph neural network library based out of PyTorch. This adapter lunch and learn session will cover PyG Basics, PyG to ArangoDB, as well as ArangoDB to PyG. Once again, timestamps are made available in the description should you wish to fast forward. Thanks for joining us, and let's get started. PyTorch Geometric is a library built upon PyTorch to easily write and train graph neural networks for a wide range of applications related to structured data. We've installed the required dependencies for PyTorch Geometric along with the import statements needed to run a few PyG Basic examples. The following snippet below creates a homogeneous graph with 3 nodes, 0, 1, and 2, 4 edges, as well as a node feature matrix X. We rely on the data constructor to create a homogeneous graph within PyG. In this example, we create a heterogeneous graph with 3 edge types, 2 node types, a node feature matrix, and an edge feature matrix. This is done by first creating the hetero data object, and then we can specify the different edge types we want to have. Of course, the edge index attribute stays, and this is how we define our graph connectivity for each edge type in COO format. Lastly, we create a node feature matrix specifically for the user node type, and we create an edge feature matrix specifically for the plays edge type. In this example, we use the fake dataset constructor along with the fake hetero dataset constructor to create 2 graphs, a homogeneous graph and a heterogeneous graph. We also use the edge dimension attribute to specify the number of edge features per graph. Note that when the edge features is greater or equal to 2, then the property representing those edge features is edge underscore attribute, which is a feature matrix. However, if the number of edge features in the graph is 1, then it'll be represented as edge underscore weight, in which case won't be a feature matrix, it'll just be a list of values representing the edge features. Next, let's take a look at setting up our adapter. I've installed the required dependencies, and I've also fetched temporary cloud credentials for demo purposes using the ArangoDB Cloud Connector package. Following that, I've created my DB object out of the Arango client, which is based from the Python Arango driver. And lastly, I have instantiated my adapter here, passing the DB object into the ADB PyG adapter constructor. Finally, I've also imported some sample data, and more specifically for our case, we'll be using the ArangoDB IMDb movie dataset. And so I've imported that using Arango Restore, and I've created the ArangoDB graph associated to that data. If we take a look, we can see that we have our movies collection, which looks like this. We also have our ratings collection, which looks like this. And finally, we have our user collection, which looks like this. And so because of that last snippet, we also have created a graph representing these relationships, which we will use later on in the adapter. Let us now take a look at PyG to ArangoDB usage. For this specific set of examples, we'll be using the following fake hetero data graph, which has a few node types, a few edge types, a specific number of nodes, a specific number of node features, a specific number of edge features, as well as a specific number of unique label values. The graph, if we go ahead and print it, looks like this. In this first example, let's take a look at PyG to ArangoDB, providing the graph name and the PyG graph data object. By running the snippet, we can see that we've created a few things. We'll have a vertex collection V0, a vertex collection V1, and an edge collection E0. So let's go take a look. We can see that we have our graph created with the following edge definition. And if we take a look at some of the data, for example, in V1, you've got your feature matrix X across all your nodes, as usual. You also have your feature matrix X for V0, along with the specific label and in this case, we stay consistent with however the data was structured in PyG. And lastly, here is what the E0 edge collection looks like. It contains a mix of relationships between V0 and V1, along with notably the edge feature matrix. Next, let's take a look at a more sophisticated example of PyG to ArangoDB. We will use the optional metagraph parameter, which, if you're familiar with the Network X or the DGL adapter, this is not a new concept. And so in this case, the metagraph parameter is an optional object mapping the PyG keys of the node or edge data to either strings, lists of strings, or user-defined functions. And so here we start off by creating two subdictionaries called node types and edge types. And so let's say we're interested in creating custom behavior to handle our V0 data. We know that V0 has two properties, X and Y, so let's start by specifying these two. Next, we'll go to our edge types. Let's say we're only interested in specifying the V0, E0 edge type, so I'm going to write out the edge type and map that to its own dictionary. And I know that the V0, E0, V0 edge type has a edge feature matrix, and so that is denoted by the edge underscore attribute key. And so now we can have that key there. And so we've got three spots here, and we are going to handle these three data sets, X, Y, and edge attribute, in a custom fashion. For specifically V0X, let's say I'm just interested in doing something simple. I just want to rename my feature matrix when stored in ArangoDB. I don't want it named as X, I want it to be named as features. So this is the first supported value within the PyG to ArangoDB metagraph. Let's say next I'm interested in handling the edge attribute for my edge type. From the example above, if you recall, we know the number of edge features in advance. We have exactly 2 features per edge in our edge feature matrix. And so this is the second supported value in this metagraph. We can specify a list of strings. So this will instead now break down this edge attribute tensor into 2 ArangoDB attributes. The first element of the tensor will be under the A attribute, and the second element of the tensor will be under the B attribute. This is the second supported value in our metagraph. Finally, let us now take a look at the third supported value in this metagraph, which is a user-defined function. So let's say we're interested in converting this Y tensor into 2 different values and 2 different ArangoDB attributes. And the list of strings really doesn't do it, because the Y value, you'll notice, is not a feature matrix. It's simply a list of labels. And so what we'll do is we are going to call a function called yTensor2column data frame. And so this function allows the user to define whatever behavior they want, so long that this function returns a pandas data frame. And the reason why we have to return a pandas data frame is because under the hood, the adapter is working with pandas to help you export your PyG data into ArangoDB and your ArangoDB data into PyG. So both the tensors and the data frame, the pandas data frame, are 2 essential data structures when working with this adapter. And so we will pass this function, we won't call it, and so this gives us an interface to do whatever we want. Let's say that we want to create 2 ArangoDB attributes out of this. The first one will be the actual Y value, so the label in terms of in numerical format, and then the next one will actually want to give the string equivalent value of that label. So I'm just creating a simple map here, and I'm going to then from here create a pandas data frame, and I'm going to specify the columns. And this is where I get to basically create my custom behavior. So let's say I want 2 attributes out of this tensor. I want label underscore num and label underscore string. Okay, great. So I've created my data frame. I can now populate this data. So I am going to now set the label num ArangoDB attribute to the values associated to the tensor. And then finally, I'm going to set the label string at value to the mapping of label num So label num dot map, and so this will map all the values set to in the label num column to the label map dictionary that we've defined above. And finally, we will return the function, the data frame. And so this is what a complete metagraph example looks like. Let us now call the the PyG to ArangoDB API. So I'm going to once again type adapter PyG to ArangoDB. I'm going to specify the fake data graph name. I'm going to specify the data as seen in the example above. And then this time I'm going to specify metagraph. And so what this does is it's going to take this metagraph and it's going to, for specifically V0 and V0, E0, V0, it's going to provide this custom behavior that we've mapped. And so just to clarify, we also are going to specify the explicit metagraph flag to false. And this tells us whether to take the metagraph at face value or not. Since it's set to false, what this means is that the node and the edge types omitted from the metagraph will still be converted into ArangoDB. If you were to set this to true right now, what you'll see is that the ArangoDB data will only include V0 and E0, V0, E0, V0 edge relationships. It won't include V1 or the other edge types that we've seen above. For now though, let's just set this to false because we're interested in bringing everything over, and we're making an exception here because we want custom behavior for these specific node or edge types. Okay, let's run the snippet. So we can see we've created the graph with all of the node and edge types because explicit metagraph was set to false. Let's go take a look though at the ones that matter. So V0, you'll see now has a feature matrix as usual, but it has since been renamed to features. And this is the result of our first custom behavior in our metagraph. You'll also see now that we have two ArangoDB attributes representing the Y values from your PyG graph. So you've got your label num, which is the original Y value associated to that V0 node type, but now you've got your label underscore string, which is now the string mapping of that Y value. This is, again, all of this is thanks to the user-defined function that we've created that creates a data frame out of the PyTorch Geometric tensor associated to the Y labels. Next, let's go take a look at E0. So we know here that because explicit metagraph was set to false, you'll see your old edge types brought over as well, right? So you'll see V1, E0, V1 is brought over, etc. So instead, let's just go and query all the edges that specifically belong to the V0, E0, V0 edge type. And so these are all our edges. What we're interested in though is seeing the custom behavior we've created via the metagraph. And so now you'll see, instead of having an edge feature matrix in ArangoDB, instead of having a list with two elements, you've successfully broken down that list into however many number of features you have, right? So in this case, we knew that that number was 2, so we were able to create a list of 2 strings, and that creates the ArangoDB attribute respectively for each feature, or for each feature within each edge. So just to recap, these are the 3 supported values currently, at least, in a PyG to ArangoDB format. So to end with our PyG to ArangoDB functionality, let us take a look at one last approach, which involves using a custom ADB PyG controller to define how PyG nodes are handled when going from PyG to ArangoDB. This also applies, of course, to PyG edges. And so this is very similar to the ArangoDB Network X adapter controller, where we have a moment before inserting the PyG node into ArangoDB, we have an opening where we can provide user-defined behavior. So just reading this out loud, this method optionally modifies a PyG node object before it gets inserted into its designated ArangoDB collection. So you're given the PyG node, which is a object representation of that node. So it's got, in ArangoDB style, it's going to look like this, for example. It's going to have your ID label, or most likely your key. blah, blah, blah. And it's going to be most likely empty because, of course, as you know, a PyG node is only represented with a number. So you'll have your PyG node, and this is where you're free to modify that node, knowing its collection however you want, right? So this is an alternative to the metagraph if you prefer to do everything all at once over here. So let's just go ahead and run the snippet. We can see that we've created our collections, so let's go and take a look. More specifically, we only modified the nodes. So if we refresh and if we take a look at v0, you'll see that of course you now have your foo attribute in your v0. Everything else remains the same, of course. You'll have your v1, which will also include foo. So this is another way of modifying your PyG graph before ArangoDB insertion. Let us now take a look at ArangoDB to PyG functionality. Similar to the NetworkX and DGL adapters, the ArangoDB to PyG offers 3 different types of transitions: transition by graph name, by collection names, and by metagraph. So in this specific example, we are going to convert a ArangoDB graph into a PyG graph by only specifying the graph name. And so we've decided to start from scratch. So this snippet above here just recreates a PyG graph and places it into ArangoDB, and it's now called fake data. So if we run the snippet below, you'll see that the PyG graph has been recreated with the same number of course, edges for each node type, or sorry, for each edge type. But what you'll notice is that the features and in regards to the nodes and edges have not been brought over. This is functionality that is specifically reserved for the 3rd transition type, which is transition by metagraph, and we'll see that very soon. Just note for now that the ArangoDB graph to PyG API does not carry over ArangoDB attributes back into PyG. The ArangoDB collections to PyG API works similarly to the ArangoDB graph to PyG in the sense that it also does not bring over edge or node features, but this time you can rely on the vCalls and the eCalls parameter to specify the vertex collections and the edge collections that you'd like to bring over into PyG. We've now reached the ArangoDB to PyG via metagraph solution, which offers 3 types of metagraphs. In this first example, we're bringing over ArangoDB data into PyG that is already formatted to PyG standards. To clarify, let us take a look at the fake data graph. So we've got v0, and if you recall, this data is already formatted to PyG standards. It's got a attribute called x, which contains a list of features, and it's got a y attribute for the labels. The same case for the edges. You know, they've got their own list that contains the feature matrix for that specific edge. And so when we are dealing with ArangoDB data that's formatted like this, we have our first implementation of the metagraph, metagraph underscore v1. Similar to the PyG to ArangoDB metagraph, we create an ArangoDB to PyG metagraph. And so this is now categorized by 2 primary keys, vertex collections and edge collections, and we now specify what is the ArangoDB attribute that is associated to the node feature matrix that we'll create. In our case, it's called X, and what is the list that contains the Y labels from the ArangoDB database, and in this case, it's also called Y. So I know this looks a bit confusing, so just to clarify, if I go to v0 right now, and let's just assume for the time being that instead of having it called X, we'd call it features and just a bunch of data, or just a bunch of a random string, right? So if this was called features, then in your metagraph, you would swap out the X string value with whatever your list is named here. And so this features underscore whatever is now going to be used to map to the X node feature matrix for your v0 node type. And so this concept can then be extended to not only your node feature matrix, but your Y labels, your edge attribute, or your edge weight if you prefer to work with edge weights instead. And so This again assumes that your data in ArangoDB is already in numerical format. This attribute exists on all your nodes of the V0 collection. So these are pretty big assumptions to make, but this is a use case that people might be interested in where you just want to bring over your ArangoDB data as is. It's already formatted to PyG, and you just wanted to have it in a PyG graph. And so here we can see in the first print statement, I show the new graph that we've created from the API. And you'll also see that this is the original PyG graph that we created just a few moments ago. And so we can see that these graphs line up. They have the same number of edges. They have the same number of nodes. They have the same node types and the same edge types. And so this is the first implementation of transition by graph name, specifically using metagraph v1. Let's say that you're now dealing with ArangoDB data that is not formatted to PyG standards. For example, let's take a look at the IMDb movie dataset, which has, for the movies, a bunch of ArangoDB attributes, more specifically pertaining to the genre of that specific movie. 0 being false and 1 being true for the given genre. And so if you're interested now in converting non-PyG structured data into PyG, you can utilize this new version of the metagraph v2, which will accept encoders or user-defined functions. We will see the latter in the last example, so let us now stick with the encoders. So the concept of encoders is taken from the PyG read the docs, more specifically the loading graphs from CSV tutorial, which does the exact same example we're covering right now. It takes the IMDb movie dataset as a CSV file and converts it into a PyG graph through these user-defined encoders. And so what you'll see in the adapter is that through the metagraph interface, you can actually specify your own encoders or rely on the two built-in encoders that the adapter provides. So let's read this metagraph from top to bottom. Once again, you have your two categorizing keys, which have nested dictionaries. And so this specifies the vertex collections and the edge collections that you'd like to convert to PyG. We want to specify some custom behavior for the movies collection, so let us do that by specifying the X node feature matrix. And this time, instead of relying on a string value, just like we did above, we are now opening the node feature matrix to its own dictionary. And so this implies that we want to build a feature matrix from the following ArangoDB attributes. And we are now using the action and drama attributes. And in this specific case, these are two attributes that exist on all of the movie documents. And we are using the identity encoder to prepare this for tensors, for PyG ready tensors. And so if we look at the identity encoder, I'll best explain this just using the read the docs. And so this identity encoder converts a list of floating point values into a PyTorch tensor. And this is the current implementation of the identity encoder, which we also happen to offer already as a built-in encoder in the adapter. And so you can just import that and use it straight away. Next up is our Y label. And so this one, not much is different from the example above. The only thing that changes is we're just pointing it to a different attribute name. And so because we don't want a label matrix, we just want a one label per node, you can directly map your Y label property to an ArangoDB attribute so long that that attribute is formatted numerically. And so let's say we're interested in having the label set to the comedy genre. And so it's as easy as specifying the comedy key. And so this will now be mapped to your Y property. Next, we'll take a look at how we build the node feature matrix for users. And so here we specify, once again, two attributes, the first one being the gender. So we're interested in taking the gender of the user, which is currently in string format, and we want to turn it into a numerical format. And we do so using the enum encoder. The enum encoder takes one optional parameter, which is a custom mapping. By default, it will just incrementally assign a specific number to each value. But in this case, if you're interested in providing custom number mapping, you can say, okay, well, for M, I'm going to designate the number 55, and for F, I'm going to designate the number, I don't know, 78, right? And so this is also possible. However, the default behavior, if you don't specify the mapping, is just incremental assignment. And so we can actually omit this since we do want incremental assignment. And we also take in the age, and we do the same thing here. We refer to the identity encoder to encode the age attribute and create an entire feature matrix out of it. And so under the hood, just so that you understand, by providing this line here, we actually build a tensor out of this, a tensor that contains action values for every movie node. And then we also do the same thing. We create a tensor for the drama value, and what we'll do under the hood is we'll use the torch.concatenate API to concatenate these two tensors for every node. And so that's how you'll get the node feature matrix. And so you'll have something like this, for example, for movie 1, the action value will be 1, the drama will be 0. For movie 2, you'll have both 0. And then for movie 3, you'll have, I don't know, 0, 1, etc., etc. And so this is what you get when providing a dictionary value when specifying a specific PyG property. And so I hope this wasn't too confusing. If we go ahead and run the snippet, what you'll see here is I will get rid of this and we'll just print the entire graph. And so let's do that. And so we'll export the movies documents, the user documents, and then the ratings. And so what you're left with here is a movies graph, a PyG heterograph with a movies node type. And let us more specifically look into what we have. So let's do this instead. So if I open a new code editor here, or a code snippet, and I print, let's say, PyG movies. So let's just take a look at what that looks like. So we've got our feature matrix X, which represents, once again, the first element being the action genre, and then the second being drama, etc., etc. And then you'll have your Y, which is just a list of labels, in this case mapping to the comedy value or the comedy genre of each movie. We can also check out users. So same thing here, you just have a feature matrix and you have 0 for, I believe, male, and then 1 for female, and then you've got your ages in the second slot. And then if you're interested in checking out the edge type, there's only 1 in this graph, so we can just fetch that. You'll see that you have your edge index, which maps your from and to nodes, and then you'll have your edge weight, which represents the specific rating that a user has assigned to the movie that they've watched. So this concludes the version 2 metagraph solution. We do have a separate notebook that clarifies use cases, and feel free to open an issue, or feel free to open a discussion with me if more clarification is required, as this is arguably one of the more sophisticated and complex functionalities for the ArangoDB PyG adapter. The last example covers the metagraph v3 implementation, which now can use user-defined functions to customize behavior when going from ArangoDB to PyG. Let's go back to our original fake data example just for simplicity. So similar to the PyG to ArangoDB metagraph, where we have an option to provide user-defined functions, there is also an option to provide user-defined functions when going from ArangoDB to PyG. And it's as simple as mapping a function without calling it to the X property, Y property, or whatever data property you want to create within your PyG graph. In our case, we're doing things very, very simple just for demonstration purposes. So for the creation of the X property or the X node feature matrix for your V0 node type, we're mapping it to a user-defined function that pretty much does what the default behavior of ArangoDB to PyG, in specifically the first metagraph solution, where we basically take the whatever key as is and return it as a tensor. I'm just doing this for simplicity's sake, but just know that this function will take as input a data frame that corresponds to the v0 data, and so you'll have access to all the attributes, all the ArangoDB attributes of that v0 collection in the form of a data frame. What's next is for you to decide how you want to return a tensor from that data frame. And so you're free to do whatever you want here. You can, create a larger feature matrix. You can reduce it to just a list. As long as a tensor is returned here of the same size of the number of v0 documents, then the adapter will take that and create PyG data out of it. And so this specific metagraph supports named functions and also supports lambda functions. Again, for simplicity's sake, the functions don't really do anything useful here. I just want to make sure that you are aware of this functionality. And so if we run the snippet for right now, we can see that our graph is also converted. This is probably a graph different from the other examples that I've shown, because I had to regenerate the PyG graph. So please feel free to disregard any worry if you notice that the number of edges or the number of nodes is different from the examples above. I had to do something off camera, but now just know that this is also a supported value in terms of the ArangoDB PyG metagraph. And so to quickly wrap up, if we scroll up, we've seen so far encoders as the values. We've also seen strings as the values, and now we've seen functions. And so you, of course, are free to mix and match. This is not 3 different metagraphs that must contain only one specific value type. Similar to the PyG to ArangoDB metagraph, you can, of course, mix it up. For the sake of simplicity here, I just decided to split these different value types, or split the metagraphs by value type for now. And so yes, this concludes the ArangoDB to PyG demos, and it also concludes the entire adapter. All right, so this concludes the ArangoDB PyG adapter lunch and learn session. I've left some useful links in the description below should you be interested to learn more about the adapter. As always, feel free to reach out for any feedback or inquiries, and for now, all the best.